inviting me over, and thank you for staying here so late. This is getting late. I think it has been a long day already, particularly for me, I guess, with jet lag. But thanks for staying. You said clinical leadership. It's a clinical lectureship, not leadership. I am representing the work that we do at Imperial College in London. Some of you might have been lucky already to hear either maybe Robin Card-Harris or David Nutt talk about some of our work, or some of the other team members. So what I will do here is I will bombard you with a lot of geeky brain stuff, in particular in the beginning, and then it will be a little bit more soft in the second half of it. So don't run out of the room if you look at too many brains in the beginning of it. It will be a little bit less so hard science toward the end. Just to mention, we are, as Brad also kindly introduced, we are not just doing psychedelics research in our lab. We do in particular brain imaging, and we look at the neuropsychopharmacology, in particular in addiction. So we do studies in opiate addiction, cocaine addiction, alcohol addiction, gambling, and so on, where we measure different transmitter systems in the brain with these imaging techniques. We do work in the GABA system, in the opiate system, in the serotonin system, in the dopamine system. So that's kind of what we do. And then personally, I also work at the moment half of my week clinically as a psychiatrist and see patients. So it's a bit of a mix. But then we are doing these studies with psychedelics. We have been doing work with, in particular, Psilocybin over the last 10 years. First in healthy for a number of years in order to sort of find out how we can work with these drugs and what are they doing in the brain, and what are the neurobiological correlates of the psychological effects. So that is some of what we've been doing. And then more recently taking it into clinical studies in depression. We are also investigating other compounds, so not just psilocybin. We also have been doing work with MDMA and with LSD, and currently we are doing interesting work with DMT. So not ayahuasca, but the pure compound DMT. We give it intravenously, so we are conducting those trials as well in healthy people. So I'll jump directly into the serotonin synapse in the brain. So this is where a lot of these compounds work. So if you look presynaptically, let me see if I can use the cursor. I can't. I don't know if there's a pointer. Yeah, okay, it might be difficult to see anyway, but on the presynaptic side, that's where a drug like MDMA works. It works by releasing a lot of serotonin, so it boosts serotonin out in the synapses of the brain, whereas the psychedelics, the classic serotonergic psychedelics, they specifically stimulate one of the 14 different receptors in the brain serotonin system, the receptor called the 2A receptor, the serotonin 2A receptor. That is the one that the psychedelics, they stimulate. And that is through that receptor that they have their main action. And that means that if you selectively block the 2A receptor, our colleagues in Switzerland have been doing that, and if you do that, you take the psychedelic experience, the tripping effect away from the drug, and not only that, you also remove the mood improving effect of the drug. So a lot of the important action is mediated through stimulation of the 2A receptor in the brain. We also know that the more potent the psychedelics are as psychedelics, the better they are at stimulating the 2A receptor. So it's a pretty key receptor. And it's also a receptor that we can image, so we can use PET imaging, which is a radioactive kind of imaging where we inject a pharmaceutical that is radioactively labeled, and it can then selectively bind to the target we're interested in, and we have some radio tracers that can bind specifically to the 2A receptor, and that is what has been done here in this is an average of more than 100 healthy volunteers, where you can see that there's a lot of warm colors in the cortex, much less deep in the brain, So this is where there are a lot of 2A receptors in the cortex, in particular in the dorsal cingulate. You heard a little bit about that area earlier. It's part of the default mode network, and it's part of where we have this sort of sense of self located in the brain, to be a bit rough. And then there are also 2A receptors deep in the brain, but not enough to proper image them with these techniques. But it doesn't mean that there are no receptors. They are a bit all over the place, but in particular in the cortex. And then just a little step backwards. So what is the importance of these receptors, these 2A receptors? What we know about them is that if you look at depression, it's a bit up and down what the studies have been showing in terms of how they are regulated in depression. And one of the reasons is it's quite difficult to do studies in depression because most often people have been treated or are under treatment, and the treatments that we give, the normal pharmaceuticals we use in psychiatry, now I stand here represent the evil psychiatry using normal medications, but I mean that is also my job, sorry about that. But some of these medications obviously work in the serotonin system, so they also affect the system that we measure, so therefore it's a bit... But if we instead look at healthy people and look at vulnerability markers of depression, so some of traits that are related to development or increasing the vulnerability of developing depression, one of those is neuroticism, is one of the big 5 personality domains, and people who are high in neuroticism, they have a high likelihood of developing depression and anxiety disorders. And if you look at that trait, it's related to increased levels of serotonin 2A receptors. And that has been shown in a couple of different studies in the Copenhagen group. Not only that, but also pessimism in people with depression is related to high binding of 2A. So there's something about that. If the 2A is upregulated, that might be a bad thing. It might be that it's because it's understimulated with serotonin itself, which is the endogenous ligand we have in our brain, important for regulation of mood and other things. If these receptors are not stimulated enough, maybe they upregulate as a compensatory mechanism, and that might be why we see these things. So, and that's another reason why it might be a good idea then to help stimulating this receptor, and that is what we are trying to do by using 2A agonists, 2A stimulators, and those are the psychedelics. Then I noticed, and I made this slide today, actually, not completely, I mean I took some pictures from somewhere else in our work, but it's a bit of an old study, but I put it in because Fadiman was, I think, saying that there's not a lot of research into sort of what are the long-term effects of using psychedelics on the brain, and then I could happily revive this paper that we wrote some years ago, because this is actually measuring the serotonin system in recreational users of MDMA, ecstasy, and also of psychedelics. And what we can see here is that if we look at the serotonin transporter, so this is an image of the serotonin transporter in the brain. Now it gets a bit geeky, don't worry, you can catch up on a later slide if you're lost on this one, but the serotonin transporter is sometimes used as a measure of is the system still working, or is it sort of really pushed into its knees by either because of something neurotoxic has happened to the brain so that it loses serotonergic neurons. So these serotonin transporter can be a marker of that. And what we found was that heavy ecstasy use, so people who have used a lot of ecstasy, they actually really do differ from healthy controls when we measure this thing in the brain. So they have significantly, these are the ecstasy users, they have much less serotonin transporters. It looks like a lot of this is reversible, so if people don't use any ecstasy for almost a year, maybe it reverts to normal, in particular, at least in some areas of the brain. But what is interesting for you, this audience here, is we're speaking about the psychedelics, and that's why I put it in, that if you look at these are the psychedelic users, they do not differ from the control. So it doesn't look like the serotonergic system is really pushed down by use of psychedelics in the same way. It doesn't look like it takes damage. And this is just the same in numbers here. You have the ecstasy group, they are lower in the serotonin transporter, but the psychedelic users are not. Then if we, instead of looking at the serotonin transporter, we look at the 2A receptor, so the psychedelic receptor itself if we measure that with PET imaging and again compare users of the drugs to people who have not been using, so non-drug using controls that are matched on age and gender and so on, then here the ecstasy and psychedelic users have been combined because they both have a direct or indirect stimulation of the 2A receptors. So therefore I pulled them together and called them serotonin 2A agonist users, because both drugs have an effect directly on the or indirectly on the 2A receptor. And looking at that, then the 2A receptor is in fact a little bit downregulated, and that might be a good thing. As you saw before, it seemed to be a bad thing to have high levels of 2A receptor. It's related to pessimism and neuroticism, and stimulating it with these drugs, this is recreational uses, seem to downregulate the receptor a little bit. And currently we I recently sent in a grant application to try to look at 2A receptors in a more controlled setting, so in the psychedelic therapy setting, where we want to measure the 2A receptor and see whether the therapy that we give with psilocybin downregulates the receptor and whether that is predicting the outcome. So try to find out a bit more about what is the role of serotonin 2A receptors in depression, how does it relate to what we see with fMRI imaging. You have already been shown today some of the work that we and others have been doing with functional MRI, which is more unspecific sort of brain activity and networks, but here we have something very specific. We can actually measure the receptor, and with very smart and fancy new imaging technique we can combine it, because recently somebody clever has developed combined scanners, so we can do PET and MRI at the same time. So that is our dream. If somebody wants to sponsor us, it's incredibly expensive. So, but you know, fingers crossed that somebody will. Okay. So I was, alarming you that I would show a lot of brains in the beginning. So here even more. This is just to recap what we have been doing over the last decade. So we have been giving psilocybin in a lot of studies. First, we did it in a scanner that wasn't a real scanner, just a mock scanner, in order to see if people could tolerate getting psilocybin inside a massive tube. And people tolerate that well. So therefore, we dared taking it to the next level and actually give it to, again, healthy people who had experience with psychedelics, inside a real MRI scanner. That was, you heard earlier, it was like being in a bin with a lot of people hitting on it, and that's a pretty good way of describing it. It's a slightly noisy and strange and a little bit claustrophobic environment, but people had interesting experience from that. They felt that they were in the womb or in a rocket in space or something. So we have been doing giving psilocybin, and in all these studies, these are all in healthy. We mainly MRI. We've also done EEG and MEG, some other techniques, and we used it intravenously. So when we use it intravenously, we inject the psilocybin, and again, I have to apologize. We are not using the real plant. We are not allowed to. We get it synthesized from a lab. But if it helps, it was Albert Hofmann who first synthesized psilocybin, so we are sort of following that, or somebody is following that recipe and giving us the pure psilocybin that we could then inject into these volunteers. So when we inject it, the psilocybin effect is quite short and it's quite neat. It's quite perfect for imaging because it's very easy to control. It lasts for around an hour, so it's nice and neat for us to use it in that setting. So all this we did in order to sort of collect data, understand the drugs better, and also to prepare and find out, is there any evidence that, can be used to support our idea of bringing this further into therapy, into a clinical population, more specifically into people suffering major depression. And so when we were, and I'll show you some of these data, but before I show you, I'll just mention that we at some point thought we were going to take the same model, keep on using intravenous psilocybin, but because the effect is quite short, we thought, and also it's not very practical for the future to keep on using it intravenously, a bit like the ketamine, so why not use the oral formulation so we can have a longer effect, so that the session and the therapy has a little bit longer and more gentle onset and so on. So we changed to oral when we went into patients. You'll see that later. Here, I think it was also shown earlier by our Brazilian colleague in the morning, that what we found with fMRI when we gave these healthy people the psilocybin was that there was decreases in the brain activity measured with different modalities of MRI. So it was not just one, two different modalities of MRI. The brain activity decreased, and it decreased in particular within this ego network of the brain called the default mode network, the network that is engaged when we sort of just daydream and let our mind flow without engaging in activities or interactions with the world around us or actively engage in tasks. So this sort of resting state network that have these regions that are active when we self-reflect. And they include medial prefrontal regions and also the posterior cingulate that I already mentioned, and also some other regions. But so the activity there decreased. And interestingly, one of the things, you look at big meta-analysis of depression, one of the most consistent findings with fMRI is that the activity in depression is increased in medial prefrontal anterior cingulate areas of the brain. So remember, this is in healthy, this work we did here, but it's interesting because we decreased the activity with the psilocybin, or the psilocybin did it, we didn't, but we measured it. And so we decreased the activity in the medial prefrontal cortex, an area that is hyperactive in depression. And other treatments that have shown to be efficient, and you might notice that placebo is one of them. So when placebo, which it does, you also saw that earlier, it can have antidepressant effect, of course, in studies. It can, all these different effectful treatments of depression, more or less effectful, but they all have been shown to have antidepressant effects. They decrease this area of the brain. So we added psilocybin to that list, which was again building evidence why this might make sense to further develop this model as a treatment model for depression. And so what I just showed you before was that the activity in these different areas went down. Another thing that we can look at with MRI is connectivity. And what is that? That is basically the sort of notion and acknowledgement that the brain obviously is not just one blob here and one blob here. The brain is developed into functional networks. So there are different areas of the brain that sort of are engaged together in synchronicity. So they work together when we do different tasks. And that is how the brain sort of matures and develops into a more sophisticated way of, but also more rigid way of working than it is in childhood. So when areas are in different parts of the brain active together at the same time, that is when we talk about that they're functionally connected. That is functional connectivity. So relatively simple. And so that is the default mode network. That is exactly that those are areas that are active together. And then there are other functional networks that I won't go into here that are doing other things and are also sort of working to the networks, the regions within each network are working in synchronicity. Here we can see, this is not from our study, this is studies that have been done in depression while we were doing our healthy work, and we could see that some of these areas within the default mode network that we saw decreased activity in, some of those areas in depression are hyper connected. So they have increased functional connectivity, so they're sort of stuck together and being active in a too synchronized way in depression. And that includes the posterior cingulate and medial prefrontal cortex. And actually, you can see that the more these are functionally connected, the worse in a sense, because the more people ruminate. So rumination, sort of this rigid being stuck in a thinking circle that is difficult to break, which is a classic trait of depression, that you're sort of stuck in these thoughts, that is related to these areas of the brain being too connected functionally. And what we saw again in healthy with our fMRI scans was that connectivity between these areas are broken down a bit, it's decreased. So again, another tick on the list of why this might make sense to develop into a treatment in depression. And then this slide from the I don't know if people have it now, it's pretty old, the Lego movie. I'm Danish, I'm proud of Lego, but that's not why I have it. It's because it's so basically, when the brain matures, I already mentioned, from childhood to adulthood, these networks, they start developing. That means that areas of the brain find out that they are engaged together in order to solve specific things. And that means that they become more and more active together in these networks, and the different functional networks become more and more separate from each other. So in childhood, it's all one big mess, in a way, and then it becomes more sophisticated, and that helps us, be more sort of specific and focused in our way of dealing with the world and solving tasks and develop higher cognition. And as you could see, if it becomes too much and some of it becomes too connected, it starts becoming even completely rigid, and people start ruminate. So there's also a flip side to the coin. In the Lego movie, you have the father who is maybe sophisticated in some way, even though he plays a lot with Lego, but he does it in a very adult and very rigid way. He is basically, he does not want a space Lego man to be over in the Wild West Lego world, because they are separate, they belong to different systems, different networks maybe. So he's gluing them so that you can't move them, so they are placed in the Lego world that they need to be in. And the child, his son, he's screwing up all that work, because he is leading secretly the rebel force in the basement of the house, where he allows all the different Lego to play around in the other system, in the other worlds. And that represents a little bit what's actually what I just described about how this brain develops into a more separate but more rigid way of working. And you even have this beautiful ball from our psilocybin work in your program, I saw. So here, the different colors here, you'll see it on a bigger slide in a moment. So the different colors represent different networks. So each little, you can't see the small balls, but they're small balls. They represent regions within a network, and they are mainly communicating within its own network. That's how it works. That's how the adult brain works. But if you start breaking that down, and you start sort of letting these networks fuse in together, and basically going a bit backwards into the more childlike state, then suddenly the networks don't really exist in the same way. Suddenly areas are active in synchronicity with areas that don't belong to the same network. And that is basically what the mathematical model that you have in your program is representing. I can't really explain the math of it. It's pretty complicated, I think, but that is basically what it shows. So this is not really the child brain, but it's the same idea. This is similar to the child brain in that way, and this is actually the psilocybin state of the brain, which allows for potentially this more flexible, adaptive way of thinking, more free cognition that is characterized by the psychedelic state. And then just to say that if you go even younger, so the younger sister of him is even younger, she is even more flexible and introduces Duplo Lego, which is too much even for him, because he has started becoming rigid already at that state, at that age. And here you have the beautiful colors. And here you can see a quote from one of the healthy volunteers in one of our early trials. There was a definite sense of lubrication, of freedom of the cogs being loosened and firing off in all sorts of unexpected directions, illustrating a bit what we see with the imaging. So all this led us to daring taking this a step further, taking this drug that you all know about, psilocybin, into a clinical population and conducting this open label pilot trial. So having some of the same issues as we heard about this morning, it's open label, so we lack the placebo condition, the control condition, which makes us all needing to be a little bit more careful about interpreting the data. But nevertheless, you'll see the data here. So this was a trial with psilocybin in treatment resistant, a word that I think Fatima didn't like, which I can understand, but anyway, it just means that people have been treated with a number of different antidepressants, minimum 2 different classes. They have had psychotherapy and so on, and they are still depressed. And then they are defined as having treatment-resistant depression. So it was in that population, and we gave a 10 milligrams sort of mediate dose, and then a high dose the week after. The 10 milligram was also to satisfy ethics in order to show that people could tolerate the psilocybin, and then we gave them 1 week after the high dose. We carefully screened, and I think there was an important question this morning. I heard somebody referring to his mother suffering from schizophrenia, and how, what about that, and should she be maybe trying psychedelics? We are not to stand and be the wise guys of who should do what and try these compounds, but I would say it's a bit of a worry to give psychedelics to people who have active psychotic illness like schizophrenia. I would at least be worried, and we also screened that out in this study. So we did not include people who had a history of mania or psychosis, schizophrenia, and so on, and not even people with first-degree relatives with a history of psychosis. So it was unipolar depression. Then we prepared people for the experience so that the mindset, and also got accustomed to the setting that we were using, and then we were guiding people through it, and you will see it in a couple of slides how the setting was, and then we tried to integrate the experience together with the patients afterwards a couple of times in the week after. And so together, this is all set and setting that Professor Phelps was also referring to, which is incredibly important. And this is just to say, it's not only the last 60 years we have been focusing on that, even though I think the term was a bit coined by Timothy Leary, at least in a couple of papers in the 60s, but it was actually something that was known from 100 years before. So in the 1840s in Ile Saint-Louis in Paris, one of these beautiful little islands in the middle of the Seine, there was basically a weed smoking club where quite prominent people like Victor Hugo, Baudelaire, Balzac, Dumas, they met and smoked a lot of weed, and they were incredibly intellectual about it, I'm sure, and they described basically both set and setting. They described how important it was for the experience, the mindset, and what was happening around them. So it was actually described more than 100 years before it was coined in the 60s. But it didn't really reach the medical field, even though I think this club was sort of initiated by a psychiatrist called Moreau. Anyway, I don't know why it didn't really make it to the mainstream. This is our incredibly stimulating environment at the Hammersmith Hospital. So you can see how we respect the indigenous use, these thousands of years of experience that, so we were dreaming of doing it out in a forest or, you know, in a castle. It's somewhere incredible. And then, you know, and that's also what we heard earlier this morning, how difficult it is to do clinical trials. It takes a lot of time, a lot of effort, and you need to convince quite a lot of people, get the funding and so on. So when we became more and more realistic, we were like, oh, okay, we are gonna do it in this. And it wasn't even just in this room. We didn't even have a specific room, so we had to have different rooms, different days. But what we did, we tried to make it a little bit more like the Mass Chapel for the Good Friday experiment in Boston from '62, and other beautiful settings in South America and so on. So we decorated the room as well as we could. Oh, this is difficult to see, but so we used dim light. We had music inspired by the Johns Hopkins list of music, but changed a bit with Mendel Kalin, one of our PhD students who has now finished his PhD. He's also a musician. He sort of created the list, some of it from Johns Hopkins and some other, a lot of sort of atmospheric and also classical music that sort of were building up and supporting the experience, and maybe even making it stronger, as he has also shown. I won't go into that line of the work, but it's quite interesting what the music is doing in a trial like this. And then using dim light and having fresh plants in the room, and different drapings and ornaments in the room as well. So we accustom people to the environment before the experience, and then here we sit 2 psychiatrists, and Robin Carhart was also there, so 2 psychiatrists and a psychologist, which is also a bit of an expensive model for 7 hours. But this was obviously our proof of concept, our first trial, so we were also incredibly cautious and also very curious about being part of it and being part of this guidance of these patients that went on this amazing journey with psilocybin. It was in 20 patients, 6 women, 44 years old, most of them severe depression, 2 of them moderate depression, and they were all, as you remember, treatment resistant, according to the definition of that. And then they have had a lot of different medications before, and most of them were weaned off, like in the Brazilian trial you heard about with ayahuasca. A couple of them were still on medication. I don't remember exactly how many. You can see it in the paper, only a few of them. And it can be a problem, and particularly one of the popular antidepressants called mirtazapine, it actually is a blocker of the 2A receptor, so that's not a good one to be on for a study like that, because it will block the effect of the psychedelic. And they have been ill for many years, these patients. So I go directly to the results. You might have seen it already. It's a couple of years old now, or almost already. But for the people who haven't seen it, I'll just show it. You can see that after 1 week, the depression score, so this is one of the measures of depression, is a self-rated, but it was very similar to the clinician-rated measures with the HAM-D and MADRS that was also used in Brazil. And you can see we had a bit longer follow-up, up to 6 months, and now you'll see the messy data. But in overall, this is the average, the black ones here, you can see it significantly drops, and it actually stays remarkably down, goes a little bit up, and some people do go back up, which would also be almost a bit too good to be true. If we just have cured everybody with treatment-resistant depression in a trial like that, we almost wouldn't believe it. But as you can see, good effect sizes in this trial, and as you pointed out earlier, absolutely right, this is effect sizes based on their own comparison at baseline, because we didn't have the control conditions, so that's really difficult to compare on that sense. And not only the depression symptoms, but also anxiety symptoms up here went down, and hedonia went down, and suicidality went down, and everything that you can imagine that you would want to have to go down in depression went down in this trial overall. And here are a couple of reports, the more subjective experiences. So I think I'll just read the first one, and you, if people want a PDF of some of the slides, I can create that and give it to Brad at a later point, so you can read it more. You can read it also in the papers, I think. So for decades I've battled with depression, the awful feeling that you don't matter, you are not making a difference, that everyone else is having a better life, the utter pointlessness of all, getting no real enjoyment for anything. That is how they explained. No, this is, sorry, I'm getting it wrong here. This is obviously before, during, and after for the same patient. So let's take the after situation here. Although it's early days, yet the results are amazing. I feel more confident and calm than I have in such a long time. My outlook has changed significantly too. I'm more aware that it's pointless to get wrapped up in endless negativity. I also feel that if I've seen a clearer picture, I can now enjoy things the way I used to, without the cynicism, without the oppression. At its most basic, I feel like I used to before the depression. So these kind of reports. And this is to say that obviously this is not the only trial. There are some other trials ours is here, but there are some of the other trials that have been mentioned during the day that show promising early data in depression. Some of them are the Johns Hopkins trials, and importantly, they actually did have a placebo in those trials. So they used methylphenidate, the ADHD medication, as an active placebo because it gives some stimulation. It's a very meaningful drug to use as a placebo for a psychedelic, because it's very difficult to blind people for a psychedelic experience, as you can imagine, and as you heard before. But methylphenidate is one way. We just did our feasibility trial, but the Johns Hopkins data is very, very similar to ours, and very convincing data, as you saw on some of the slides earlier, also from Fred Barrett, who represents the Johns Hopkins group at this conference. So there are all these promising results from these studies. And then just to say that we are also trying to tap into the real world, not just doing our lab work, but we are also setting up online surveys, so people who out in the real world experience these drugs, they can sign up online and consent if they plan to do or go through a psychedelic experience anyway. They can then sign up, and then we measure a lot of things online before they have the experience and then around what they experience, and then some follow-up 2 and 4 weeks in this online trial. So this is not published yet, but as you can see from this data set, this is the depression scores here, and so these are just people who are using it maybe with their friends and some magic mushrooms, maybe in a retreat with ayahuasca, but people who out in the real world have used a psychedelic, and their depression scores, and are they depressed? Some of them were depressed on their self-rating, some of them were absolutely not, but if you look at overall the depression ratings, they go down significantly, very significantly. So similar to what we saw in the trial, it also seems to work to do it in a naturalistic setting. Also, anxiety symptoms were reduced. And this is an illustration of these are the people who, from their self-rating, are actually severely depressed when they have the experience, so a baseline, and these are moderate, and these are not depressed at all. And as you can see, obviously the more depressed, the more effect it has, the more it goes down, which is nice, but also makes sense from a data perspective, and the same with anxiety symptoms. Then I just want to touch upon a theme that when we did our trial and we got more and more experience using psilocybin, we were discussing internally if we should sort of pinpoint one term that we found interesting and maybe quite important for what people experienced. It was connectedness, so that we independently of each other actually had come up with, if we should use one word to explain what it was that people seemed to find through the experience, was a sense of being reconnected. And Ross Watts, the psychologist in our group, she wrote a paper, and you'll see it a bit later, and defined this. So I won't go through the quotes because I think it will take too long, but people felt a greater sense of connectedness to their partners, to their family and friends. And again, you can read the quotes in the slides if you want at a later point. To strangers. It's one of the patients, it's maybe not exactly connectedness, but he was describing, he had a pretty challenging experience during the trial, one of the depressed patients. So in the end, we were like exhausted, all of us. But he said that the days after, he was standing by the bus stop, and there were like 4 different people who approached him and asked him questions. And he said normally people never did that. So he had some other sort of aura around him and appeared more approachable than he used to. So that was an interesting sort of report that he gave us. That's not what's written here. But anyway, people seem to connect better. And sometimes not just with humans, but the world in general, and with nature. And also nature relatedness was increased. There's a scale for that. There's scales for everything, but also for nature relatedness. Tree hogging kind of sense. And that could also be picked up with that scale, that people increased in that. And this is from Ross's paper, Ross Watts' paper, that one of these key themes from the study was that people felt reconnected. And also we have published recently a paper that one of these aspects of connectedness was related to the increase in well-being. So this is just to show, because now I only showed relatively old data from the brain in terms of what we have seen in healthy, so I thought I should also show a little bit about what we saw in the depressed patients. So here comes a little bit more brain stuff. So using cerebral blood flow with what is called arterial spin labeling, is one of the methods where you can quantify blood flow in the brain with fMRI. We saw that one of the regions in the brain that was decreased was the amygdala, and amygdala is often increased in depression, the activity in amygdala. And we saw a decrease, and not only did we see a decrease, we also saw that the degree of the decrease in activity was correlating with the depression, the improvement in depressive symptoms. And with connectivity, we saw a decrease in connectivity between parahippocampus and prefrontal cortex. Again, increased connectivity has been seen between those regions in depression, and also that correlated with treatment response at 5 weeks. Then one thing that is interesting, you have seen it already on some slides, and you've seen that the effects seem to be quite sustained over time. So even though it's just a one-off session, in our case it was 2 with a week between, but after this one session, people remained much better for months. And that is not just in our trial, that's sort of across the different trials. This is the work for a review that hopefully soon, relatively soon, will be finished. So this is trying to look at that there seems to be a sustained effect after these one-off sessions with psychedelics used to treat depressive symptoms, and also anxiety for that matter. And this is just to compare with the ketamine. You also saw it earlier, that the ketamine also has a nice antidepressant effect, but apparently more short-acting. So people need to be redosed with the ketamine. Maybe people also, at least some people, will need to be redosed in the future models using psychedelics for treating depression, might need to be redosed, but maybe less frequently than the ketamine. That's how it looks now, at least. And so what is happening? How can it be that people they get a drug? I mean, the pharmacology of the drug. It's not that the drug is still in the brain. The brain, I was going to say, the brain disappears. Hopefully not, but the drug disappears from the brain. So there's no drug left in the brain the day after you have been giving people psilocybin. It has a half-life of some hours. It's gone the next day. So how come that the effect? And that is why this is a fascinating new paradigm in a way. Maybe not completely new, but for a lot of psychiatrists, at least, it's new, and pharmacologists, it's peculiar and new, because we are giving one-off treatments, pharmacological treatments, and we see long-lasting effects. How is that possible? The short answer is that, of course, we don't know, but you guys probably have a lot of good ideas about what it is that provides this healing effect of these drugs. But one thing that we can, again, we like to measure stuff when we do research, is that we can try to pick it up on personality parameters, because if you are modulating people's personality, that's a more rather than a state, more a trait marker, something that is more sustained. And one of the ways to assess personality is to use the NeoPeer, which is a 240, it's a very long self-rated questionnaire, and you end up with dividing the personality into 5 different domains. Neuroticism, as you already heard a bit about, I mentioned earlier, is the one that is a vulnerability marker for the affective disorders. Extroversion, openness, agreeableness, conscientiousness. Those are the big 5 with a lot of the personality models. And if you use the big measure, the 240 item, you can also subdivide it into 6 facets. So for openness, it's both openness to fantasy, aesthetics, feelings, actions, ideas, and values. So openness to other people's way of thinking, broad-minded tolerance of others' viewpoint and value. That is what is sort of covered by the trait openness. And you already, in the just the talk before mine, people were referring to Catherine McLean's from Johns Hopkins studies showing that openness is increased, and I think it comes here, that openness significantly increased, and the more mystical the experience had been, the more open people were, even more than a year after the one-off session. And these were to psychedelic naive volunteers in the Johns Hopkins trial. And in some data we have from Copenhagen, where we did this imaging trial you saw on the first slides. So this is a cross-sectional recreational users. Openness is actually increased among the psychedelic preferring users. So not among the MDMA preferring users, and not among the controls. And the only trait of the 5 that differed between the groups was that openness was higher in the psychedelic users. If you just saw that, you might say, yeah, okay, they are more open because it's cross-sections, there's no causality. they are more open, therefore they use psychedelics. But because of the Johns Hopkins data, where they actually accounted for causality because they measured it before and after a psychedelic experience in psychedelic naive people, then suddenly this is a little bit more interesting. And it was also in that data that the lifetime use of psychedelics was correlating with openness. That paper is hopefully soon coming out. It's submitted. And in one of our other trials, the LSD trial we did in healthy, openness also increased a little bit after 2 weeks from baseline, even though they were actually experienced users. And the more the increase in openness, that was related to how chaotic the brain, how shaken the brain was in terms of entropy during the experience as measured with fMRI. Then just say that depression typically is related to high scores of neuroticism, a bit the same as I said earlier, and lower in depression and extroversion. That's typically what is seen in people with depression. Now I'm going to, in a moment, in a couple of slides, I'll show you what we saw in terms of personality measures in the depression trial. But before, I'm going to go into a little bit about the theory about personality. So is personality something that is just stable and doesn't change in the healthy adult? A lot of people say yes, it should be stable, that's why it's a trait. But as was also mentioned in the previous talk, some of them, they gradually change, or maybe not gradually, but they do change a little bit over time. So openness go a little bit down with age. And you can also see agreeableness, conscientiousness, and this is sort of the inverse version of neuroticism. So if emotional stability is the opposite of neuroticism in these measures, so that changes a bit with age. But then does it change gradually, so very slowly changes in personality, or could it be that maybe personality not, because if you do measure something and then years later measure it again, you don't know if it was gradually changed like this, or whether maybe it was happening more stepwise with very impactful life events that could maybe, but you won't really pick it up if you just measure it. And there's not that much known about that. But there are some interesting, brilliant papers about quantum change, psychological papers about how, and it's some of it very old thoughts back to founders of modern psychology as well have been describing this, that very impactful, profound, maybe spiritual experiences can change people quite dramatically, which is some of what we see with the psychedelics. And one of the ways of looking at that was defining what is called a peak experience. You've already heard about that because earlier, so I will go a bit quick, but Abraham Maslow, a great psychologist who also described the pyramid of needs and so on, he described the peak experience as rare, exciting, oceanic, deeply moving, exhilarating, elevating experiences that generate an advanced form of perceiving reality and a rare, even mystical or magical effect upon the experimenter. And was one of the people who conducted some of the early work together with Timothy Leary and also together with Bill Richards from Johns Hopkins, Walter Pankey, who conducted the Good Friday experiment at Johns Hopkins. He compared the psychedelic experience that you have already heard on several talks today, so I won't go through these terms that are characterized by the psychedelic experience, but they overlap massively with the psychological peak experience as termed and coined by Abraham Maslow. Abraham Maslow didn't conduct psychedelic experience, but it was very similar, the thoughts about that. This is to mention, and you have seen it before, it was also presented in the previous talk, that the profoundness, the nature of the actual psychedelic experience seems to be predicting the clinical outcome. And that was also the case in our study. So Leo Rosman, he published this, but so this is for our depression trial, but very similar in a number of other trials that you have seen referenced in other talks today, that the peak or the degree of mysticism in the psychedelic experience is a predictor of positive outcomes, both clinically and on well-being if it's in healthy people. So we measured with this big instrument personality before and also 3 months after in our depression trial. And what we saw was, so this is baseline, so the red is personality measures at baseline, and the black is sort of norm data. So this is sort of norm data, and you can see that neuroticism at baseline, not surprising, these were depressed patients, they were severely depressed. They scored higher on neuroticism at baseline, they were lower in extroversion, and not very different in agreeableness and openness. And in theory, this should have been a bit less open than norm data because they were depressed. However, people who signed up for our trial probably were pretty open to begin with, maybe, because otherwise they probably wouldn't have dared being open to the idea of using a psychedelic at this stage to treat depression. So that might be why they were not lower than the norm, and then lower on conscientiousness they were as well. And this is then the 3 months data. So 3 months after, so this is after this one-off 25 milligram dose of psilocybin in these depressed patients, you can see that this dotted line is suddenly moving towards the norm, and it's overshooting with openness. So again, there is an effect like that Johns Hopkins saw, that openness increased. We also saw that here in a depressed population. So we could see that the different personality traits moved towards the norm, and openness increased further. And this is the facets. I think it'd be too much to go into the details about those. And then, so I think here it's important to sort of think, okay, what do we know already about personality changes when treating depression? Because is this an effect of the psychedelics, or is it an effect of whatever you treat a depressed person with, and you measure trait personality after a while? Is it then changed? And yes, it is changed in trials treating people with depression. So neuroticism should go down and extroversion should go up. That has been shown in trials of treating people with depression before. And what I did, I went into one of these recent big reviews and went into the one that had used the same measure as we had with people who have been treated with SSRIs and so on, and then looked at the effect sizes and compared it to our effect size in order to see whether we saw the same or whether there were some differences. And as you can see here, if you look at neuroticism, here is the average effect size from normal treatment trials in depression, and it's very similar to what we saw. So neuroticism goes down, similar to what it does in other trials. Extroversion goes up, but it does it more than twice as much as you would expect from the other data, and openness increases more than 3 times more than you would expect based on what has been seen in other trials. So there might be something in particular specific about psychedelic experience, both in healthy people but also in depressed patients, where the openness is increasing, and that might be more than what you would expect just from treating people. It might be some of what the psychedelics are actually facilitating, is this change in openness. And again, back to our online survey, again, not published yet, but soon will be, hopefully. And as you can see here, openness, these are the p-values, the change from baseline to after this experience that people have had out in the real world. Openness goes up. Emotional stability, again, is the reverse of neuroticism. So emotional stability goes up or neuroticism goes down in these people after this experience. And then conscientiousness, not much, and agreeableness also increases, and extroversion as well. So they're overlapping with what we saw in the lab in the depressed patients in a bigger sample from the real world after a psychedelic experience. Also, these changes are coming up. And interestingly, if you look at if you divide these people who were not really depressed, but if you look at the self-rating of depression and divide them into people who actually fulfill criteria for depression based on their self-rating, then you can see that it's the people who were depressed who increases in extroversion and in emotional stability. So this is the same as going down in neuroticism. Whereas the people who are not depressed, they don't really change much. Whereas openness, again, which supports that openness, it might be more specific psychedelic thing, because for the openness, it's both the people who are depressed and non-depressed who changes. Okay, so there might be something there with openness that is quite interesting. And now this is my last slide before the acknowledgement, and this is just to show what we are doing and what we want to do and what we are naively hoping to be able to do if we get a whole lot of money. For instance, this one is an expensive one. So we are currently, I'm doing the depression work with a PET tracer called SIMPI36, which is basically an NBOM 25. It's a psychedelic that we use in a microdose radioactive version, so we can measure the 2A receptor. So it's an agonist, it's a stimulator of the 2A receptor, and we can measure that. And it seems, we have found out, it's not published yet either, that it's sensitive to changes in the brain's own levels of serotonin. So when people go down to the GP and are told that, oh, you're depressed, it's because you don't have enough serotonin, now we are going to give you a drug that increases your serotonin. You can, if somebody ever tells you that, you can say to the GP that he doesn't know or she doesn't know, because we can't measure serotonin in the brain, but now we can, we think, with this method. So this is the first study actually measuring serotonin in the brain, and we are now doing that in depression to see if people with depression are different in their ability to release serotonin when we're using amphetamine to release the serotonin. We could also use MDMA, but we're using amphetamine. And then we're doing the next level of psilocybin, and all the same as our Brazilian colleagues are brilliantly doing with ayahuasca. We are also trying to do it in a more stringent manner in order to get a control condition. So we are comparing it to SSRI treatment in a more sophisticated and bigger setup, bigger design, in order to overcome what is a placebo effect and what is the real effect of the psilocybin. And then we're doing the DMT, as I mentioned in the beginning, and then we are setting up a number of microdosing trials, and I'll do advertisements. So if people want to take a picture and remember this site, and if anybody is thinking about doing some microdosing in the near future, then hopefully this study will be launched online on this site at some point in July. And it's a self-blinding, and this is a very new, novel, slightly innovative idea of following a manual that we have made, and we have had it approved by ethics, that people can self-blind. So we overcome the expectation placebo effect that is the problem with microdosing, that there is no evidence yet that it actually does anything. It could all be placebo. We are trying to get around that by doing this self-blinding version, which is heavy to explain how it works, but you can see it in the manual if you want to do it yourself. And want to spend an afternoon self-blinding yourself at home, then please do that. It's not online, but it's going to be on this site, and hopefully launched in end of July. Yeah, and then I want to thank, of course, and I won't mention all these names because that would be like Oscar meltdown. But Robin Carhart, of course, and David Nott are the main two people leading this work in our group, and then a lot of people have been involved in all these different studies, and thank you to them and the people who have helped funding it. Thank you very much.